Design a patterned soap holder using simple, repeatable methods, a format that works well for STL sales. Go with a hybrid design. It keeps the option open for multiple components. Press S to open design shortcuts. Start your first sketch on the horizontal construction plane. Press S again to open sketch shortcuts, then search for a slot. Use the overall slot. It's quick to set up, but one downside is that it won't center on the origin. You'll see why that matters later. Set dimensions based on your soap size or follow along with mine, 100 mm long and 40 mm wide. A quick time saver. Skip finishing the sketch and press E to extrude directly. Set the height to 10 mm. It's low profile while keeping print time and filament use down. Use shell to remove the inside. Set the wall thickness to 3 mm. We'll come back to that later. Press Ctrl+5 to switch to shaded view with hidden edges. Now measure the straight section of the 100 mm width. Use Inspect. The middle section is 60 mm. Create a new sketch on this side. Here's one downside of not centering your design on the origin. When you start a new sketch, the view recenters to the origin. Not a big deal, but something to be aware of. Press and hold the mouse wheel to pan into position. Place a center rectangle roughly in the middle. Set it to 10 by 2 mm. Press D to add dimensions. You have 60 mm total. Subtract 2 mm for the rectangle. That leaves 58 mm. Divide by 2, that's 29 mm to center it on the side. If you use a different method, drop it in the comments. It's a good habit to check your design from different angles as you go. Looking at the bottom makes it clear right away that it needs a chamfer. I'll add a sleek 0.5 mm chamfer and see how well that distance prints. With the bottom chamfer in place, it's time to wrap the pattern around the soap holder body. Start by measuring the total distance around the soap holder. The sum of your selected edges appears in the bottom right corner as you work your way around the shape. The total length is slightly above 245 mm. The center rectangle sketch is 2 mm wide. Extrude, cut it 1 mm for a clean detail. When you apply a pattern on path using this cut, the spacing ends up slightly above 4 mm once the 2 mm width is taken into account. Set the compute type to path direction for a clean result. Start with the feature and the path. You can drag the feature around the model to get a feel for the tool. Change the distribution from extent to spacing for better control. Set the quantity and distance based on the calculation from about a minute ago. Then change the compute type from identical to path direction as instructed earlier. Your pattern is now evenly distributed around the body. Take a moment to inspect the model from different angles using the view cube and catch any issues before moving on. Continue with the new sketch from the top view on top of the soap holder body. Use Project to create linked sketch geometry that updates with changes to the body. You'll recognize it by the purple color. Offset the sketch 1.5 mm to leave room for the top surface and a bit of clearance. Extrude cut the new sketch 2 mm. This creates a shelf where the top of the soap holder will rest. I haven't validated these thin dimensions on my 3D printer yet, but they're easy to adjust in Fusion if needed. With the shelf in place, start working on the pattern tray. Create a new sketch on the shelf and use Project again to keep the model parametric and linked to earlier steps in the timeline. Offset the sketch 1 mm and extrude it 1.25 mm. This is likely too thin for a real print, but the focus here is the Fusion workflow, not final dimensions. Set the operation to new body so we can turn it into a separate component later, then confirm with Enter. Place the pattern on the top of the soap tray. This pattern is both aesthetic and functional. Start with a center rectangle. (34 mm high and 1 mm wide. Position it in the middle of the tray. It's easy to eyeball, but it would be trivial if the design were centered at the origin from the start. Extrude, cut the rectangle through the top surface. This works for a one-off model. If you plan to iterate, don't hard-code the cut. Tie it to user parameters or reference geometry so it updates with the body. Use the rectangular pattern tool to build a pattern. Switch the object type from bodies to features since the pattern is driven by your extrude cut. From the top view, it can be hard to pick the right feature. If that happens, just grab it from the timeline instead. Pick one of the sides as your axis and set the direction to symmetric. When you're working with symmetric patterns, use an odd number of instances. That keeps the pattern evenly distributed on both sides of the original feature. There's no magic to these numbers. Iterate until you find a balance that works for the design, the look, and the function. The nice part is you see the update live as you tweak the settings. I'll settle on a distance of 30 mm and a quantity of 19. That gives me 9 feature cuts on each side of the original. If you followed along, here are a couple of extra tips I left out to keep the modeling fast. Turn your two bodies into separate components. You can do it now, but it's even better to set that up earlier before you model each part. Also, consider adding user parameters. That makes it much easier to adjust and reuse your design later. If this was useful, subscribe to the Maker Letters for more Fusion and 3D printing tutorials. And check the description for tools, deals, and extra resources. See you in the next one.